Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 90 in our incredible new tutorial series where you're learning how to think like an engineer using the Arduino Uno R4 Wi-Fi. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons, and in this class, we will be using the Sunfounder Elite Explorer Kit. Now, hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to show you is my homework solution to the assignment from last week. Now, where we ended up with last week on Python on the desktop running PyQt5, we created a program that would allow us to more precisely calibrate our magnetometer. And what we ended up with was three graphs that we would look at the same time, and then as we rotated our project, we could make sure that we were getting all the way out to the actual max and xmin, ymax, ymin, zmax, zmin. We wanted to get those actually very precisely determined because those are the numbers that we get our calibration parameters from. And it's much easier to do it if you can look at a visual as you are spinning the project around. So that worked great. We got really great calibration factors, but remember we had this square window and there was 1, 2, 3 panels of graphs. That bottom panel, the bottom right panel, was empty. So I said, let's create a graphic in there that is a compass with north, east, south, and west, and then a compass needle that goes around to graphically show us after we've calibrated what heading we're at. And so I'm going to show you my solution for that today. Hopefully some of you guys got it done. And next week we're going to move on. We're going to complete our PyQt work today. I know sometimes you guys get a little weary of the PyQt. If you do, just, my solution will be on the website. Just go get it if you don't want to go in and code all the PyQt stuff. If you say, I'm here for Arduino and you got me off in this Python PyQt stuff, well, just use the code that's on the website, and we'll be back next week over focusing on the Arduino. Okay, so let me get out of your way. There we go. And what we want to do is we want to start with where we left off last week. And so you need to go to the most excellent www.toptechboy.com. You want to use this happy little search tool, and you can search on last week's lesson, which was Python PyQt5 magnetometer calibration program. You'll come here. This is the very simple code for the Arduino. I'm not going to copy it because it's already running on my Arduino, but you put this, run it on your Arduino, and then you'll come down and you'll come down here, and this is the program that we're going to start with this week. Okay, so this is where we left off last week. This will do the calibration and make those three graphics. We're going to get that. We're going to come over here and we are going to paste it. Let's run it, make sure the universe is working properly, and make sure that we can actually copy and paste correctly. Okay, all right, so that's looking good. Let me move this up here where you can see it. And then let's rotate this thing around, and you can see that we're making nice circles. We're getting all of our data, and you see the big white blank spot in the lower right of our window. And so what we're going to be doing there is we are there going to be putting our compass graphic. Okay, sound pretty fun. I hope you think it's going to be fun. Okay, so now what I'm going to do is I'm going to go back up to the top of this code, and we're just going to make some changes to add that fourth panel down there. One thing that we're going to need to do here is when we import PyQt5, in addition to the things we're already importing, we're going to need Qt GUI. Pay attention to the capitalization. It is very important if you want it to work right. And then also what we're going to be doing the calculation of heading over here on the Python side, which needs the arctangent function, which here we need to import math to get that arctangent function. That is looking good. That is looking good. I think we're going to probably need to add some variables here. So we're right now have these arrays xcal, ycal, and zcal. But what we're going to need is we're going to need just a variable to read the individual numbers into. And we're going to put x equals 0, and we're going to put y equals 0, and we're going to put z equals 0. And you're probably saying, well, last week you were just reading directly into the variables in the function, and that worked. Well, that's true. But what we're doing this time is at the very end, we'll be applying a low-pass filter to our data to smooth it out a little bit. And the low-pass filter is always like x plus x, some factor of x nu. So you have to seed those readings with the low-pass filter with something so the program doesn't crash the first time it sees it. Okay, so we got those in there. That is looking good. Now this is setting up the widgets. This is setting up the widgets. We've got the status label. We've got the min-max label. We've got the calibration button. We've got the plot layout. Okay, all of that is looking good. To create our three plots, then the data that goes in the plot, it's a scatter. That looks good. Okay, and then we add those in, and then we come down here, and then we start working on the programs to activate the button. Okay, well, what do we want this time? We want a fourth panel, right? We need a fourth panel. And so I'm going to call that heading plot, and that's going to be equal to a PG for PyQt. You know, that's what we the graph. That is the, let me do it very precisely. That's the PyQt graphing we imported as PG. Okay, so we'll be referencing PG. And so our heading plot is going to be our graph. It's going to be a PG dot plot widget. And we're going to give it a title is equal to, our title of that is going to be equal to the heading. Okay, and I think we'll call it compass heading, the compass heading. All right, and now we'll close that. So now we have created that panel. Now we've got to give it some parameters. Well, the heading plot, we want to set aspect locked is true. That sets the aspect ratio to be a constant, and that way if you resize it, it doesn't make it odd shapes. So that's just a good thing to do. And then we're going to heading plot dot. Now this wants to make a graph, and so it's going to want to put a set of axes in this graph, but we don't want the left axis or the bottom axis. We don't want those because we want this to look like a compass. So we just sort of want that circle floating out there. So what I'm going to do is I'm going to say show grid, and I'm going to go ahead, I'm going to show the grid. So I'm going to say x is equal to true and y is equal to true, like that. So we can have the grid, but then on the graph, what we want to do is we want to set a minimum size for this widget. Okay, this is really pretty much like we did last week, right? So I'm going to set a minimum size just like we did last week on those other three. The minimum that I want it to be is 300 by 300. So if you try to resize smaller than that, it will lock you out. You can't get smaller than that. All right, so now the axis itself, this is what I started saying earlier, but I started saying it too quickly. The axis itself, I don't want to be on. So I'm going to say heading plot dot hide axis, and I want to hide the y-axis, which is what? The left axis, like that. Okay, then I want a heading plot. I want to hide axis, the bottom as well. The bottom would be the x-axis and the left is the y-axis. So I'm going to turn both of those axes off, so I just have a circle that is floating out there. Now what do I want to do with this? I want to plot layout, and I want to add widget. And what do I add it to? That heading plot, that the plot layout, the overall plot layout, I'm adding heading plot to that I just created. Where does it go? Well, it's 0 row, 1 row, so it's on row 1, column 1. So that'd be the bottom right empty spot there, right? So that would be 1, 1, like that. So I think that is pretty good. I don't know. Let's see if this does anything. I don't know if we'll get something there or not. If we do this, we might actually go ahead and get something. Line 70, what did it not like? Heading plot, line 70, heading plot. There we go. That's why I like to check it as we go along. Hopefully you guys saw that mistake when I made it. Okay, now look at this. What we have is we have an empty panel down here, but the panel has been created with the compass heading title. So we are doing pretty good. Now what are we going to want? We are going to want a circle. Okay, we are going to want a circle. And so what on this plot, I'm going to create a compass circle like that. And I do that. How do I create a circle on my graph? I do an ellipse, ROI. And what we have to see is a circle is just a special case of an ellipse. And so this is really just, I don't think there's a circle command, but you just make the ellipse into a circle. Now, what do we need to do? Where are we going to put the center of this thing? Well, I'm going to make the radius all the way around. I'm going to make the radius 3. And so I want to put it at -1.5, -1.5 in X and Y for the center. So the X value of the center is going to be -1.5 and the Y value is -1.5. So that's going to be good. Now I have to tell it the radius. The radius, like how long is it along X, and then how long, this is more like diameter. What's the length from left to right? And then what is the length from top to bottom? And so I'm going to make that 3 and 3. And so that should work very well, 3 and 3. And I think I'm going to make those floats. All right, so now I've kind of defined my circle, but let's do a little bit of work to say what we want that circle to look like. What we want that circle to look like is we want to do a pin, and then I'm going to do a pg.makePin, and I'm going to make the pin blue, which means the circle will be blue, and then I want the line to be kind of heavy, so the width of the line is going to be 4, so it's going to be a very distinct circle that you are going to be able to see like that. And then do I want it to be movable? No, I don't. I don't want to be able to move it around. And then do I want it to be resizable? No, I don't. Now, it allows you to go in and like it puts handles on it so you can resize it, but I don't want it to do that. Okay, I don't want it to do that. So I'll say resizable is false and movable is false. And so hopefully that won't put those little handles on our circle for resizing or for moving. All right, now what we can do is we can say the heading plot that we just created up there, I want to add item to it of the compass circle that I just made. Okay, like that. Let's see if this will run. Look at that. Very good. Very good. All right. Now I told it don't resize, but what do I see here? It put those handles on there. Okay. And then you see I can resize with those handles even though I didn't want to. I can resize and move with those. And so I tried to get it not to do that, but it did it anyway. So I have to kind of tell it louder, right? I got to tell it louder. So what I'm going to do is compass circle dot remove handle, and that'll remove the first handle, and then compass circle dot remove handle again, and that should remove the second one. And then compass circle dot set z value to 0. Okay, so this should take those handles off of it. Now, right, we've got an XY plane. We've got an XY plane, so we're looking at a graph in X and Y. And then why am I putting the circle at 0, Z? Because as we get the needle and other things, I want to control who's in front. So I'm going to put the circle at 0. And now if I want something in front of it, I just make Z a little bit bigger than that. And so that should allow us to get things looking good where the parts are intersecting. So let's look at that. Hopefully the handles will come off of that thing this time. Line 80, compass circle set Z value at 0. Little c. All right. Do you see why I like to run it? Because it's easier to debug, because I know, the error is in the last few lines of code, and so it just makes it a little, okay. So we've got a big, bold, beautiful blue circle without any little dots or resizing handles on it. So we like that a whole lot. So we've got all that. Now what else are we going to need on there? Well, we're going to need the compass needle. So it is going to be a needle. So I'll call it an arrow shaft like that. And then that is going to be pg.plot curve item. All right. Now, where do I want it to start? I want it to start at 0. And it's sort of like, what is the first point? The first point is 0, 0. And then the second point for north would be 0, 1.5. So what I'm going to do is, this is a little bit confusing, but I've got my two x values, my x1 value and my x2 value, and then I'm going to have my y1 value and my y2 value. So on x, I want both the first point and the second point to start at x equals 0. So the first point is going to be at x equals 0. The end of the arrow is going to be at x equals 0. Okay? And then for y, I'm going to have 2 points for y, y1, y2. I want the needle to start pointing up towards north, and so the first point would be 0, 0, and the next point would be 0 and y of 1.5, and so that would be 0, 1.5. I don't want to belabor this point, but this was confusing to me. The first point is the point x equals 0, y equals 0. The second point is x equals 0, y equal 1.5. So this is the y value of the first point. All right, maybe I talked too much about that. Now I want my needle to be nice and wide too, so I'm going to make the width equal to 4, and then I'm going to also make a pin is equal to pg.make pin like before. And then what do you think we ought to do for that pin? I don't want it to be the same as the circle. I don't want it to be the same as the circle. So I think I'll make the needle red. So I'll put an R, and let's get this where you can see it. I'll put an R. And then on the and I think the arrow shaft, I should not have put the width here. Okay, and I can put the width over here is, I believe, the preferred way to do it. And here I would say width equal 4. So that should put an arrow shaft for me. That should put an arrow shaft for me. And then I wanted the heading plot. That's the plot we're working on. Heading plot. I want to add item. And what do I want to add? The arrow shaft. Like that. Okay. Now I want to create arrow shaft. So something didn't finish. Oh, up here I need to finish this one. Okay. So that should work now. Now I've got the arrow shaft I've added. Now I want a little dot to go around. The dot would almost be like the head of the needle. And so I'm just going to create a dot. And that is going to be a PG dot scatter plot item. And that is going to be, where do we want it? The position. I want to start at the position. I want to start at x is equal to 0 and y is equal to 1.5. So if I make this at 0, 1.5, that is putting the dot at the second point of the line that we just made. What was the second point of the line? The 0 and the 1.5. All right. Let's make the width of that dot. Let's make the width of that dot equal to 4. Let's make the size, that's the width of the line that it's drawing for the dot. Let's make the size of the dot, let's make it a 10. Okay. And now let's make a pin. And the pin is going to be pg.makePin again. And what I want is, I want it to be yellow, like that. Now that's drawing the circle. It's drawing the circle. The dot is a circle. It's drawing it yellow. But now how do we want to fill it? Well, to fill it with a color, we're going to do a brush equal pg.make brush, like that. And then what color do I want that to be? Yellow. So the circle drawing the dot is going to be yellow, and then it's going to be filled in yellow. All right. Okay, now I'm going to go ahead and get it a dot set z value, and I want the dot to be above the circle, so I'll just set it to 1. Okay, because in Z the circle was at 0. Now the dot is going to be floating above it. You won't see it floating above it, but this keeps the line from drawing through your dot. All right, now what do we want to do? We've got it made, so let's do a heading plot dot add item. And what do we want to add? We want to add dot. All right, I hope this works here. 82, what did it not like in 82? Plot curve item. What did I do there? Plot, that's good. Curve, that's good. Item. Man. Okay, got to be very careful with your case. I had uppercase, it's got to be lowercase. That looked so right when I was looking at it. That one scared me a little bit. Okay, line 84, scatter plot item. It's probably the same. Scatter plot item should have been scatter plot item. You guys are probably making your own sets of mistakes here as I'm making my mistakes, but hopefully this will have everything on it. Okay, this is line 84. Okay, let's look at line 84. Dot is equal page scatter plot item. The position is, it wants a tuple. The position, it wants a tuple. So we got to add a tuple there like that. All right, we got to make it a tuple. Heading plot is not defined. Heading plot. I might need to change the battery on my keyboard because I think I am typing those letters in, but they're not coming in. Okay, now look at this. This is what we wanted. All right, so we've got a circle at a compass. We've got a line and a yellow dot, and it's pointing north, just like we told it to. 0, 1.5. I like that. Okay, so let's kill this. And what do we need now? We need the ordinances of the compass, north, east, south, west. So up is north, and then pointing to the right is east, pointing down is south, and pointing to the left is west. So we need to add those labels, and I'm going to add those inside of a for loop so we don't have to do this over and over and over. And so I'm going to say for angle. Now normally you think like for angle in something, like for angle in something, right? But did you know you can step through two different lists piecewise? So I can step through angle, and at the same time I step through label. And each time I go to the next angle and the next angle and label, the next angle and label. So it's stepping through, incrementing angle and label at the same time, which is different than if you try to do it with two for loops, one inside the other, it wouldn't. We got to step through two lists at the same time. So I'm going to step through angle and label in. Now when I give the two lists, I need to put zip so it knows that it's going to get two lists. And what's the first one? Well, I want to go from 0, which is going to be north, to 90, which is going to be pointing to the right, east, and then 180, which is going to be south, and 270, which is going to be west. So what angles do I want to go to? Well, I want to go 0, I want to go 90, I want to go 180, and I want to go 270. And as I'm stepping through those angles, what labels am I going to want to put on my graph? Well, 0 is what? 0 is what? It's 0 degrees, right? How does math work that the x-axis is 0 degrees? You start at the x-axis and you rotate counterclockwise from x, but 0 would be all the way to the right, which would be 0 would be all the way to the right, which would be east. And then 90 would be what? That would be pointing straight up, which would be north. Okay. And then give me just a second here. I need to recalibrate my windows over here. Okay, so 0 is east, then north, then how do we go? Over to 180. Over to 180 would be west, and then we would go to 270, which would be south. Okay. Now when we start bringing this compass to life, I'll go and I'll draw a picture so you understand those angles. It's just the problem is if I say east is this way pointing this way, you see you're looking at me with a mirrored thing, so it's sort of like the old my right your left thing. So it'll work better if I really explain it by drawing it on the sketch pad in a minute. Okay, so we close that, and then we close that. Okay, so that's going to be good. Now, so that is going to be a for loop. So we're going to step around to those 4 locations and put the labels on. And so I'm just going to say my radian is going to be, my rads is going to be np.degree. Yeah, I'll do this. So I've given it, let me see. Okay, radians, what did I do? I gave it in degrees, and so the radian is going to be the angle. Okay, the radian is going to be the angle divided by 360 times 2 times math.pi, like that. And I think that will work. So now, while I gave it in degrees, what does the math function want? It wants it in radians. So I just converted degrees to radians. And now what is my x position? My x position of the label would be what? np dot cosine of rad, right? Cosine, so the adjacent over the hypotenuse, the adjacent is the x value. And so this will give me x. Now, if I did this, what I would be is I would be at 1. But what was the radius of our circle? I think it was 1.5. The radius of the circle was 1.5. So if I multiplied this by 1.5, it would put that label right on the circle. And I don't want that. So I'm going to make it 1.8 so it's not right on top of the circle. Now, y position is going to be equal to np dot sine of rad times 1.8 again. So again, this is just stepping around. It'll put the north, it'll put the east, it'll put the south, it'll put the west, northeast, southwest. And let's put that in correctly. All right, now we need to get the text. What text? What is the text? I've got the position. What is the text? The text is going to be, I've got to create a text item. And what is it going to be? It's going to be the label. What is the label? Well, first time it's east, next time it's north, next time it's west, next time it's south. So it's going to go east, north, west, south, because what? It goes counterclockwise. So it's going to be the label. Now I need to give it an anchor. And so we're going to set the anchor at 0.5, 0.5, and that should work well. Okay. And then what we're going to want is we're going to want the color is going to be green. Right. So what is that going to do? That should put north, south, east, west, and it should put it in green. All right. Now I've created this text object, but now I've got to put the text object somewhere. But before I put the text object somewhere, I want to set the font. So I'm going to create a font is equal to Qt GUI is equal to dot Q font, like that. So I've just created a font object that I'm going to work with now. Now the font that I just created, I want to set bold. I want it to be true. So when I print this label in this font, what am I going to do? I'm going to have it be bold so it shows good. Then I'm going to say the font dot set point size. I'm going to make it a 12-point font. So that'll be big and bold. And then and you can play around with these. Now the text that I created, I've got to set its font to the font that I just created. So now that font I just created, I'm tying that to this text object. So the text set font to font. Now I've got to put its position. So the text that I'm creating, its position is going to be what? The X position I just created and the Y position that I just created. Now I've got the text items. Now what do I want to do? I want a heading plot dot add item and then text. And if this works the way I should, just with this for loop, it'll do north, east, south, and west. And that way we don't have to put this code in 4 times. So let's see what happens. Boom. Okay. Guys, I hope you're not getting weary with this, but the hard work is done. North, east, south, west. Let's see if it resizes. Okay. Yeah, you see it resizes properly with the box. The thing doesn't start doing strange things. And then you see here, I can't make it any smaller than 300 by 300 for each one of those, right? I'd set those minimum sizes. So that looks good. So that, I think, is the worst part of it. What do we have to do now? We've actually got to bring that thing to life. We need to actually bring that thing to life. And so now what I need to do is one more thing. So down below it, I want to actually have the heading as a number point out. And so like a heading of 0 would be north, a heading of 90 would be east, but I want to print that number of what precisely my heading is. So that's the one thing we're going to want to add to the bottom. So we're outside of the for loop now, but I'm going to do live heading is equal to pg dot another text item. And then what am I going to put for my text item? Now this is just the initial label. We will bring this to life later. Okay, we will bring it to life later. Oh, this anchor, I didn't say what that meant. Like I say, put the letter at some position, but then what do you want? Well, if you put 0.5, then it moves that text around based on the center of the text, not the bottom, like you could do bottom left, upper right, you know, but I want it at the center. And so that's what it is. It references everything to the center of the text by making that 0.5. I did not explain that very well the earlier time. So the label is going to be heading, and I'm going to start at 0.0. So this isn't live. This is just when you run it, it's going to show this is sort of like your initial one. And now after 0, 0, I want the little degree sign, and you can get the little degree sign with a slash, lowercase u, 0, 0, uppercase B, 0, like that. That will give you the degree sign, and then you close that. What is our anchor? Again, we want to put it reference to the center always. So the anchor again is going to be 0.5. Anchor is going to be 0.5. So everything's referenced to the center. And then my color is just going to be equal to white, like that. All right. So now that should give me a label for the heading. And then down below, we'll make it come to life. But now I think we want to do this same thing for the font again. Okay. So we're going to come here. I don't know if that font should still know that font. It should still know that font. So I think what I can do is, I can say my live heading dot set font. The font, which I've already defined, I think that should still be okay for us. And if we get any surprises, we'll change it. Okay, so we've set the font. Now the heading, the position, the live heading, I've got to tell it where I want it. And I want it at X is 0. And then I want minus 2.2 because I've got to be below the circle and below the south. And so I've got to go like all the way down to minus 2.2 so I don't overwrite that south symbol. Okay, now the live heading dot set z value, again, I think I can set it to 1 just like I did the other one, so it'll be at the same level as that letter was, the south was. Okay. Let's see if this thing runs. We should now just see a heading of 0 degrees down there if we did this right. Live heading is live heading. I am sure that I need a new battery in my keyboard because I am typing these letters in and it is hopping over them. Okay, now let's see what happened here. I did not get my heading. Did I forget to add it? Yeah, I forgot to edit it. So heading plot, that's my overall plot. I need to add the item and then the live heading that I just created. All right, so let's try that. You see, I've created the heading, but I didn't add it to the plot, so it didn't show up. All right, look at this, okay? So I've got a heading of 0 degrees. See the little degree sign? That's success. Northeast, southwest, that's success. That's all good. Guys, the heavy lifting has been done now. So now what do I need to do? I need to bring heading. I thought I told it not to let me move it, but it ignored me. I've got to bring this heading text to life. I've got to bring the position of the dot to life, and then where that arrow, that line points to life. Those three things I've got to bring to life. Okay, so let's kill that. Let's kill that. And then I think if you look here, we've got the toggle calibration. Well, this isn't about calibration. Okay, this is not about calibration. This is about update plot. And so if it's not calibrated, we don't want to move the compass around if the thing is not calibrated. But if the thing is calibrated, if calibrated, then here in this region of if calibrated is where we want to bring those things to life, okay? And so let's think about what the first thing is that we want to do under if calibrated. Well, we're still going to get the X calibrated, the Y calibrated, or the X, the Y, and the Z calibrated points, the individual points. And then we put those individual points into the arrays. That's good. Then we add the data here. That's all good. So all of this is as it was before. But now what do I want to do? I want to get the heading in radians. And that's going to be equal to the math.atan2, just like we were doing on Arduino, of what? The Y calibrated individual point over the X calibrated individual point. Now that is going to give me a headings in radians. Okay, now how do I get a heading in degree? A heading in degree is going to be equal to the heading in radians, and then there's 360 degrees in a circle, so I multiply by the 360, the units I'm going to, and then I need to divide by 2 pi, so I'll divide by 2 and divide by math.pi. So now I should have my heading value in degrees. Okay, so I've got the heading in radians and I've got the heading in degrees, and those are the right proper navigational headings. Very good. But now how do I get this to plot correctly on my little circle in PyQt5? We have to do an adjustment. And let me see if I can explain that adjustment. And so what we're going to do is I'm just going to come in and kind of show you in math how math works. So that's a y-axis. And this is an x-axis. And the way things are defined in trigonometry, 0 degrees, so this would be 0 degrees, which would correspond with north, is coming right along the positive x-axis. And then in trigonometry, positive degrees are defined as moving counterclockwise. And so if we had a heading of 90 degrees up here, it would be straight up. And what would a heading of 90 degrees be? That would be east. And then a heading of 180 degrees, that would be what? South. And then if we come to 270 degrees, that is west. So according to math and trigonometry, north is to the right, and positive is going counterclockwise, and so we would go north, east, south, west, like that. That's what trigonometry says. That's what math says. That's what we just calculated. But when we plot it, we want to plot it on a compass that people expect. And what do people expect their compasses to be? Their compasses, they expect north to be at the top, and then east, northeast, south, and west, like this. So what two problems do we have? The two problems are, I need to take the north and I have to move it by 90 degrees or pi over 2. That's 90 degrees and that's pi over 2. So I have to add 90. I have to add pi over 2 to get north at the top. And now what is the problem? Here, northeast, southwest is going counterclockwise. But if I look on the compass, northeast, southwest are going clockwise. So if I want it to plot like people expect, I have to do some adjustments. So right now I have got the heading in degrees. Well, what I want is I want a new variable, which I'm going to call compass radians and compass degrees. Now, what do I need to do? Well, on compass radians, what I need to do is I need to take the heading in radians. And what do I need to do? I need to add the 90 degrees or the pi over 2. And then it's going the wrong way, so I need to make the sign negative. And then compass degrees is going to be the same thing. It's going to be negative of the heading degrees. And I'm going to add 90. And so the compass degree and the compass radian is the right answer, correct mathematically. But how do we plot it on the compass that was defined way back in 1200 or whatever? We've got to convert the math orientation to the compass orientation. Does that make sense? Let's hope it does. Sit around and think about it. I don't want to take any more time on it, but I've explained it, and then see if that's gonna make sense. So I've got to create something now for plotting. And for plotting, I'm going to create the compass radians, and that's going to be equal to minus the head radians, the math radians, and then I'm going to need to add to that the math.pi divided by 2. So pi over 2 is 90 degrees. Now similarly, I'm going to need to create the heading degrees, and what I can do is now I can just convert the compass to degrees. Okay, well no, I'm gonna do it like what I said. It would be minus the head degrees plus 90. Like that. So what should I have now? I should now have the heading that is good in math, and I should have the heading that is good for plotting where we are. So now we got to figure out where are we, and we're going to do the math based on the compass. Yeah, this was supposed to be compass here, wasn't it? Okay, like that. So now I'm going to create the position of the x dot, and that is going to be 1.5, which was our radius of the circle, times math.cosine of compass radians. Why? Because the math function wants to work in radians. We have a radius of 1.5. That's where the 1.5 came from. And then why is it cosine? So the adjacent over the hypotenuse, that x-axis, is the cosine value. And so the y is y dot is going to be SOHCAHTOA, the opposite, which is going to be y for sine. So 1.5 times math.sine, which is going to be compass red. Right, so that should give me the x, and that should give me the y. Now, we've got those two. Now we've got to put the dot. So the dot, set the data of the dot. And where do we want the dot? We want to be at a position equal to the tuple that it wants of x dot comma y dot, like that. Close the tuple, close the parentheses, close the bracket, close the position. Let's see, set data, I open. And then position is really very strange. Position, we're going to put an open parentheses, an open bracket, and then it wants the tuple. And so you got to really get these things opened and closed correctly like that. And now I'm also going to need that arrow shaft object, and I got to tell it where to go. So I've got to do a set data on it. And then what do we have? We have the x values. X is equal to, and then this time we just do the open because these are the x values. The first x value is always going to be at 0, and the second x value is always x dot. All right, and then the y value is going to be always at 0, and then the second one is going to be y dot. So remember, this wants x is x1, x2, and y is y1, y2. And so that should do that. And now we want to do a live heading dot set text. And now we want a heading. So what am I doing here? I'm actually bringing the heading, the label down at the bottom to live. So live heading, set text, we're going to have heading equal the string concatenated with the string value of the integer value. Why? I don't want a bunch of decimal places of the heading in degrees, right? Because the math is right on the heading degrees. We only use the compass degrees to do that goofy plotting. And then plus the degree symbol, which was the slash. Make sure you do your slash the right way. It's the one above the enter key. U 00 B 0 like that. Close it. Close it. You see that? Like that. All right. Let's see if we can get our problems out of the way. So let's see where all I made errors. Okay, now I've got that. Now it hasn't come to life because I haven't calibrated it yet. So I'm not going to do an accurate calibration. I'm just going to get numbers in there so it doesn't crash. Okay, and so I'm just getting the numbers quickly so it doesn't crash. Now let's see if this thing comes to life. Okay, now look at that. All right, look at that. The dot is alive. And if I bring this over here, the dot is alive. And let's see right here. So when I'm pointing north, the dot is almost at north, and then east, and then south, and then west. And so it's not perfect because I didn't really calibrate it carefully, but the dot is alive. That means all of our math is right. And I just didn't bring that. I did somehow not bring that arrow shaft to life right. So let's see, arrow shaft. Arrow shart. I didn't spell it right. Arrow shaft. Let's try that. This time I think I'm going to try to calibrate it more carefully. Okay, and so we're running. I'm going to bring this over here. We are running. Okay, and now I'm going to do my start calibration, and I'm going to try to do it more deliberately this time. You can't see that, can you? I'll hold it up here. You notice I'm trying to tilt it by my inclination. Okay, and then do you see the blue in the XY plane? I really am trying to calibrate it well this time. So I think that is pretty darn close in the blue. And then now we're working on the XZ plane, so I'm keeping it pointed north as I'm rotating, showing that the entire magnetic vector, that looks good. Now we're going to work on the X or the YZ plane. So I'll hold it like this, and then I'll spin it around. Okay, I think those are good for the calibration. And so now let's say go. All right, now look at that, okay? So here I'm going to, it doesn't like, it says live heading is not defined. So I still got an error in here. I've still got an error in here. Live heading should have been live uppercase H for live heading. Okay, so now with live heading fixed, we should be ready to run this thing again. So let's hit the run button. There it is. Okay, so now I'm going to try to pretty deliberately calibrate this thing carefully. So what I will do is I will say start calibration. I am pointing north. I am tilted by the inclination, and now I am going to rotate about the z-axis. So I should get a circle in the XY plane, and I do want to really get up there and make sure that I'm getting X max. Do you see how I'm saying tilted by the inclination angle? They're making a beautiful circle in the XY plane. There we go. Okay, so I've rotated about Z. Now let me rotate about X. Right here is X. I'm going to rotate about X. I'm pointing north. I'm rotating about X, and I am getting a circle in. I'm getting a circle in the YZ plane. Beautiful circle. Okay, now I'm going to point north. Again, I'm pointing north. The x-axis is pointing north. And now I'm going to rotate about Y. Okay, and I'm getting now the XZ plane. Circle. Little bit more over here. Okay, there you go. So now that should be calibrated. So what we're going to do now is we're going to say stop calibration, and boom, look at that. North is pointing perfectly north. The heading is 0. And then when I rotate east, and let me let you see what I'm doing here. All right, so with north, I'm pointing perfectly north. Remember, I aligned my grid up last week with the iPhone, pointing perfectly north. North is north, and now east is perfectly east. East is perfectly east there, and then south is perfectly south, right? Perfectly south, and then west is west, and then north is north. Now, what's the one thing that we don't like? The one thing that we don't like is that when we come here, it's going from positive 180 to minus 180, to where really what we want on a compass to go from 0 to 360. You know, it's the right answer, but we don't want to go positive 180 to minus 180. We want to go 0 to 360. So we do need to do a very slight adjustment there. And the way you can kind of take care of that little problem is that we've got the head rad. That is good. When we calculate the heading in degrees, which we're going to be using, what I'm going to do is I'm going to come here, and I'm going to mod it with 360. So that says divide by 360 and print the remainder. And the way this works is that's going to take care of that problem at that one point. And we're going to take care of that there. And then we are also going to take care of it. That's at the heading degrees, took care of it. And then at the compass degree, I'm going to take care of it there. So both of those are not going to have that plus 180, minus 180. They're all going to go 360. So let's do it like that. Okay, so now let's run it one more time. I thought I was going to be finished, but I'd forgotten about that little problem. Okay, so let's see now if we get a heading that stays between 0 and 360. So I'm going to start my calibration. I'm going to do it a little bit quicker because you're tired of watching me calibrate. You are tired of watching me calibrate my magnetometer. There, and now we're going to come here, spin around the x-axis. That's good. Now we're going to spin around the y-axis. Okay, I think that should be calibrated. Now we're going to stop. Okay, now what is good? We are sitting here at 0 degrees. We're sitting at 0, and then we come to 90, and we've got right here at 90, we've got 90 perfectly. Then I come to 180, and it goes to 180, and it doesn't switch over to minus 180. It keeps going around because I did that mod 360, and now I'm at 270, which is good. And then I come all the way back to 0. Boom, that is great. Okay, now I have one more little thing for you to do, and what that is why? Okay, yeah, that's, I was thinking, where am I pointing? Okay, that's right. So now what's the one thing that we don't like? We don't like this little bit of jitter. We don't like this little bit of jitter. And so to stabilize this and not have that number jumping around, we need to put a low pass filter on it. So that's your homework for next week, is to take this and add a low pass filter to it so that we take that jitter out of the compass reading. Okay, we take the jitter out of the compass reading, and then we will have this program done. We'll be done with PyQt5 for a while. We'll go back to the Arduino side. I know you guys get a little bit weary as I'm going through this PyQt5 stuff, but I do appreciate your patience. All right, next week we'll go back to the Arduino. Okay, it's at this point that I always give a big shout out to my Patreons. Thank you guys that are financially supporting me on Patreon. That is what's keeping me in the game week after week, allowing me to create fresh, new quality content every single week. Thank you guys. You can help this video by giving a thumbs up and leaving a comment down below. If you haven't already subscribed to the channel, when you do, make sure you ring the bell to get notifications of future lessons. And most importantly, share this video with other people, because the world needs more people thinking like an engineer and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.